Hi Year 12s! This is a video to talk about sketching the addition of two functions, as well as mentioning the rules for the multiplication of two functions. First, we will look at the definition of an addition function. In order to define the addition function, we just follow the rule that f plus g of x equals f of x plus g of x. Basically, this means that we can just sum the functions together to get the addition of the functions. The domain is defined as the domain of f plus g is equal to where the domain of function f intersects with the domain of function g. Basically, the new function will only have a value at values of x where both the functions of f and g are defined. Second, we will look at the definition of a multiplication function. In order to define the multiplication function, we just follow the rule that f times g of x equals f of x times g of x. Basically, this means that we can just multiply the functions together to get the multiplication of the functions. The domain is defined as the domain of f plus g is equal to where the domain of function f intersects the domain of function g. This is the same as the domain of the addition function, in that the new function will only have a value at values of x where both the functions of f and g are defined. In order to sketch the addition function, the best way is to sketch the two individual functions out by hand, and then add them together in order to get a function that works. Then we can see over which domain the new function will actually appear clearly as well. In question 5 of the second exam in 2013, we have the multiple choice question of finding the domain for f plus g given these functions. Straight away, we can see that the domains of the two functions only overlap for the values of -1 inclusive to 1 exclusive. Remember that the square brackets are inclusive and the round brackets are exclusive of that number. This was A of the multiple choice questions and our final answer. However, let's pretend that we were also asked to sketch the addition graph. Now we would have to sketch out both the functions and then add them together, which is good practice. To sketch f of x, we need to remember our log sketching rules. We can see that the function is reflected in the y-axis from the negative in front of the x, and it is also shifted on the right from the 1 minus x in the bracket. This means the asymptote moves from x equals 0 to x equals 1, which is why the domain is defined as exclusive of 1. As the function f approaches 1 to the function approaches negative infinity, if we remember our log function shape. This shift to the right also gives us a y-intercept. To find the y-intercept, we set x to equal 0. This means the function goes through the origin, and since it is a one-to-one function and our only x and y intercepts are located at the origin. The function will also have a dilation factor of 2 from the x-axis. The other point that is important to calculate is that when x equals -1, at the other end of our f plus g domain. Now we just need to sketch g of x. We must remember the function of the square root of x will only appear in the first quadrant of the x and y axis, where they are both positive. However, the +1 under the square root shifts the square root to the left by 1, so our starting point will move from the origin to -1 and 0. The graph will also have a dilation factor of 3 from the x-axis. Let's find our y-intercept by setting x to 0. Our y-intercept is 3. Knowing the shape of our square root graph, it will therefore keep increasing at a decreasing rate. We also need to work out what the function equals at x equals 1, what the f plus g domain approaches. This is 3 root 2. Now we can sketch these on the same axis, so that we'll be able to draw our f plus g function. Now, our addition function is easy to draw, as we just need to map out the points where one of the functions equals 0, as f plus g will just be equal to the other function here. The function will start at x equals -1 and y equals 2 log 2. Then, move to x equals 0, and y equals 3 at a decreasing rate as the gradient of g of x decreases and f of x becomes steeper. The function will then approach negative infinity. The trick to drawing an addition function is to follow the curves of the two functions as best you can. The turning point of the function can be calculated through either differentiation or a function on the calculator. However, today we are just working on getting the general shape of an addition function. If any of the sketching of the individual functions were confusing, please have a look over some of our earlier videos. Thanks for watching and happy studying!